Thank you. It's a pleasure to be here, and welcome to the Warner Babcock Institute and the Beyond Benign Foundation. Glad to be here to talk to you. It's something very near and dear to my heart, and I'm sure yours as well. It's an amazing job that you guys have, and you'll see from our perspective nothing short of the most important job in the world, because we live in real difficult times. Okay, we are, you turn on the radio, you open up the newspaper, you look on the internet, and we learn EPA is considering dry cleaning cancer-causing materials, Chicago's toxic air, babies exposed to cancer chemicals, household dust, bad, bisphenol A, bad, negative, bad, evil, killing us, dangerous, cancer. Who in their right mind would want to be a scientist in 2010 with everything that's being bombarded at us that says that everything is wrong? And yet, how are we going to get out of this mess if we don't have more scientists and more people? But we're so polarized. If industry says something is safe, the environmental activist community says, oh, well, you're evil and you're just lying to us. If the environmental activists say that something is dangerous, well, they're just a bunch of tree-hugging hippies trying to make babies smoke pot. We don't have really a common ground in which people can actually talk to one another. We never talk about making things that are environmentally benign and therefore non-regulated in the first place. There's no language, there's no science to bring people together. We felt if we could create a science to have people from the DuPonts and the Dows and the Pfizers and the Roman Hearts and all of industry actually start to talk about it, then maybe we could grow a science around it. And hence was born green chemistry. The book that we wrote was this thing called Green Chemistry Theory and Practice. And I got to tell you, once this book came out, I turned into Forrest Gump immediately. This book got translated into like 14 different languages. I have been in the last 5 years to over 30 countries meeting presidents and prime ministers, and everyone talks about the 12 principles of green chemistry that we have in this book, the American Chemical Society, the Royal Society, the Japanese Society, all these different countries are all talking about the 12 principles of green chemistry. It's really just amazing. So that's why I'm really glad that you're here to learn about this and how to integrate this into your classroom. All right, so the technical definition of green chemistry is the design for chemical products and processes that reduce or eliminate the use and or generation of hazardous substances. Most important word there is design. You can't do green chemistry by accident. Green chemistry is active pollution prevention. It's not a feel-good philosophy. It's not a journal article. It's not a seminar. It must be a technology that removes hazard from the world. Therefore, yes, it has to have some environmental benefit, but that's not enough. It also has to have superior performance. No one is going to buy a cleaner that doesn't clean just because it happens to be environmentally benign, and no one is going to spend too much. But if you don't have the safety, performance, and the cost all together, it will not be successful in the marketplace and therefore will not achieve anything. And so green chemistry must have all three of those things to work. But I'm telling you, in 2010, at best, 65% these technologies haven't been invented yet. It's not that industry isn't evil. Industry isn't deciding to pick bad things because it's fast and expedient and greedy, blah, ha, ha. We're just not there. The technology isn't there yet. And we can look at this in despair and say, oh my God, what a bad situation. Or we could say, what better time in human history to be a scientist, to be a chemist, to be in this business, to say to some kid, you could be the person to turn this traditional technology into a green chemistry technology. What do we do when we go to inspire students to go into school? We bounce into there and we explode something. Boom, this blows. Oh, look at this, kids, be a scientist. Boom! All right, now, if that really turns somebody on, they probably shouldn't be going into chemistry. All right, it worked a few decades ago, but today, the video games are so much better than that. It doesn't work. But imagine coming into class in a soft voice and, hey, we got problems. There are issues. You want to really save the world and have a good job? Well, become a chemist. If I go to a party and I say to a group of people, hey, how you doing, what's going on? What do you do? Oh, I'm a chemist. talk about a conversation stopper. Okay, they look, oh, I hated chemistry, blah, blah, blah. And think of what we abdicate with that reaction. We have to take a step back and go back and ask, what message are we sending to the children when they're in grade school, when they're 3 years old? You know, if you think about it, child grows up, 4 years old, we already put them on a track. We call them scientists or artists. And we're messing them up. We really got to step back and think about that. Why is it in education that we pigeonhole people and put them in little boxes when really we've got to look at it as we're all in this together and we all have different ways of looking at things. We can all gain from that. What we've got to do is we've got to realize that the last thing is we can't despair. Imagine if Dr. Martin Luther King got up and said, I have a nightmare. Okay? What would people do? Okay, they might write, some people might write some checks. It might write some papers, but people don't get turned on to action from negativity. They only do action when they think that there's a pathway forward. And that's what we've got to remember in all this. Yes, there are issues facing society. Yes, we have a polarized society that makes any discussion difficult. But we can figure this out, and you're on the front line of making that happen. It's your students that are going to get us out of this mess with our help.